Okay, gang, we're going to factor this and find the zeros. Again, a zero is an x-intercept. It's where the function is equal to 0. The y value, it's the x for where the y is equal to 0. You can think of it like an x-intercept. We're going to do all those steps again. And each time you see this, just try to grab like a little more information. So I'll start with Descartes' rule of signs. So remember, for the number of positive real zeros, it's the variation in sign of the original. All right, so let's look at it. So from here to here is a positive to a positive, there's no change. Now from here to here, positive to positive, no change. From here to here, positive to a negative, that's your first change. From here to here, negative to a positive, that's your second change. So it's 2, and if you remember, right, you have to less than an even number, right, for the complex conjugate. So it's 2 or 0. I could not subtract 2 again because I would get -2, and you can't have a -2 quantity. All right, so it's 2 or 0. Now let's do the number of negative real zeros, how many of those we might have. So you have to take the original function. Everywhere there's an x, you have to put in a negative x. Okay, let's simplify that. If you have an odd amount, the negative lives because it's an odd amount. So the negative will come out and change the sign. If it's even, an even amount of negatives will cancel out. The sign won't change. Okay, so let's see how many negatives we have. Alright, so negative to a negative, that's not a change. Negative to a positive, that's a change. Positive to a positive, that's not a change. Positive to a positive, that's not a change. Okay, so it is 1. So when we write 1, we don't mean maybe it has 1, we mean it has exactly 1. So with the positive real zeros, it may have none. I don't know. It's got 0 here. But I know for sure I have 1 negative real zero. Okay? All right. Let me make you a little table if you'd like to see the possible scenarios. Okay, so we could have, there's one case where you have 2 or you have 0, and no matter what scenario, you always have 1 negative. This is a 5th degree, which means that the total has to come out to 5. Okay, so for this to add to 5, if I have 2 positive, 1 negative, then I must have 2 complex for this to add to 5. For case 1. For case 2, for this to add to 5, if I have no positive, 1 negative, I must have 2 conjugate pairs, or in total 4 complex numbers, for this to add to 5. Alright, that's the first step. And what this does is it helps you as you go through the problem. Like, once I find 1 negative real, I don't test any more negatives because I only have 1. I don't have 2, I don't have 3, I don't have 4, I have 5. I have 1. So even though this information is like vague, It's actually quite helpful because once you find one negative real, you don't test anymore. You don't look anymore for that, okay? All right, let's do step 2. Now, step 2 is the rational zero test. And I'll add new concepts as we go through this. All right, so this is going to be 8 over 1. So it's always the constant over the leading coefficient. Don't ever reduce anything. You're just sort of, you're going to set up a bunch of numbers so that you can do a combination. So I just write out all the steps so you can see it. So it's 1 over 1, 2 over 1, 4 over 1, 8 over 1. And then the plus or minus of each category. All right, let me just make it look a little nicer since it's all over 1. All right, so this is your potentials. These are like your starting teams, and you just got to figure out where your winners are in here, okay? I'm going to add another concept as we go through this. I just didn't want to overwhelm you too much with the first problem, but there are some techniques you can use so that it gets easier to find the answer. So here's a technique that you can use when I will use it if it applies here, okay? So there's something called an upper bound and a lower bound. If when you're testing synthetic division, you put in a positive number and you get all positives out, that would be what we would call an upper bound. Meaning, don't test anything higher. There's nothing higher than this. And I know this is a little confusing, but when you put this in here, it's not necessarily going to be the lowest upper bound, okay? So, but whatever you test here, if it comes out all positive, it just means don't try anything higher. It won't work. It's like spiraling to be too big. By the way, 0 can count as a positive or negative, whatever you need. It's sort of like the wild card. It just will help you in whatever way you need. Now, if you have a negative here, and what's coming out is oscillating, that's what we would call a lower bound. Do not try anything lower. Nothing lower will work. I mean, you can try it. You're wasting your time, but you can try it. But if you get a negative here and then this oscillates, it means that nothing lower works. And again, what you get here might not necessarily be the highest lower bound. Okay. So in the problem before, this is the part where it gets tricky when you start to test to figure out who the winners are, because this can take a whole heck of a lot of time if I'm not a good guesser. I can end up testing like all of them and be here like an hour later. So this is the part where you want to have some techniques to sort of get to the solution faster. That's why I'm giving you this, and there's something else I can show you as we go through it. So I'm going to make suggestions, but really at the end of the day, it's your test, it's your final. However you do it is, you know, how you do it. So one of the techniques to speed up the process of finding the answer is to always pick in the middle, because if you pick in the middle, it could turn out you have an upper or lower bound. So that's the logic I use when I pick in the middle. I also, since I know for sure this has one negative real, I'm going to start with the negatives. I'm not 100% this has a positive because it could have 0 positives. So that could mean I could test all the positives and none of them could work, okay? So I will tend to start here, but I have a feeling with this problem it's going to have this and this. But let's just see how it goes. So I'm going to start in the middle here. I'm going to go with -2. It doesn't mean it's right. I'm just guessing, and I'm trying to do this without knowing the answer, so that you can sort of see how crazy this gets. And we're already at about 10 minutes, so okay, here we go. Now this is missing a fourth degree, so I have to be careful when so it's at 1, it's missing a fourth degree, I got to put a 0. All right, so I'm picking in the middle. We decided, let's see here. I already forgot what I decided, gang. Oh boy. Okay, I hope I said -2. That's what I'm going with. -2. Let's see what happens. Wow, I'm going to play the lottery today. Okay, I found it. I found it. So this is it. So I just want to spell out what we found just to make sure you've got it. Right, we started with f of x. And what we did was we found one of the x values. Right, and I told you before, to put it in factored form, you got to pull it to the left. So this is in the 0 form, when x is equal to -2, y is 0, but this is the factored form when it's pulled to the left. The remainder is what tells you it's a winner. That's what you're looking for the remainder to be 0. So this is the leftover. This is the constant. This is the coefficient of that x, coefficient x squared, coefficient x cubed, coefficient of x4. All right, so these are the coefficients. This is the quotient here. This is the coefficients of the quotient. Now, you can go back to the original, but I'm going to suggest that you go with the smaller portion, because once you've started to break down the original, it's the leftover that you're trying to break down. So I'm going to suggest when you start it, the next round, you start with the quotient, right? Because there's going to be less, there's less options with the smaller version, right? Because when I do the rational zero test for this, which is 4/1, I only have these 3 items, and again, we know from Descartes' rule of signs, we know we only had one negative, so I wouldn't try. I already found it. I found the one negative. So I wouldn't try any of the negatives at this point. I would just now go for the positives, because I'm not really sure I have positives or not, but that's what I'm going to test, okay? So let me put in, I'm going to stick to the middle. Let me put in a 2. Okay, 2 did not work because the remainder is not 0. But I did learn something. Did you catch it? Did you catch it? I actually learned something from this. Even though this was, in a sense, not the right answer, I didn't leave, I'm not going to leave totally empty-handed. Okay, hopefully you caught it. This, because this is positive, and these are all positive, that means it's an upper bound, which means nothing higher works. Nothing higher works. So now, not only do I know that this one doesn't work, I know that this one doesn't work. So if this doesn't work, I'm stuck with just complex. So I didn't get the answer here, so I have to start over with the same beginning. And this is my last potential. So again, if it's not this guy, then I have to go, it's going to be complex. All right, here we go. Let's try this guy. Okay, that is a winner. That is a winner. All right, let me show you what happened now. The previous step, we had taken out one linear factor. Wow, I'm going to get cut off. I can see it, and I'm right at the end here. Okay, so I taken out one linear factor, and so now this is a constant x squared, x cubed. Okay. So that means here that x equals 1, or if I move it to the left, x minus 1 equals to 0. And then it gives me who's left. So 1x cubed minus x squared plus 4x minus 4. That's what's left. Okay, so once you get the linear factor, what you want to do is just keep cutting away at this until it becomes quadratic. So I only have one more level on this. I can't believe the camera's still recording. I'm going to stop here and pick up again in the next video on this guy. So we have to keep going. I haven't finished factoring it yet. I'll catch you in the next video. It's repeating now, so at least you get to see the steps over and over. I'll catch you again. Bye-bye.